All right, so we're back to a new lesson, and in our previous lesson, we started looking at spanning tree, and we also said that spanning tree helps prevent switching loops. And in order for spanning tree to take effect, a few things will have to happen. We saw an example of a situation where we had like three devices, so three switches, and for some level of redundancy, every switch is connected to every switch. And so we had maybe switch A, B, and C connected to each other. We also mentioned that with A, B, and C, they have ways to get to the other devices or the other endpoint. So assuming this is PC1 and this is PC2, we said that in these two devices, in order for them to communicate, there will be some kind of a broadcast earlier on, and then the port numbers is what is going to be used to record where to get to those devices. And so, for example, in my drawing, I have a few labels that I'm doing now. So if you could see here, there is F0/1, F0/2, and all that for the devices. We said that for PC1 to talk to PC2, initially, PC1 doesn't know who PC2 is. So they do that based on the IP addresses. So it sends an ARP, address resolution protocol. Um, it uses an ARP. They try to do resolution. So it asks PC1 will check its device and see whether or not this device is possible within the network. It sees it, and then it sees that the IP address is within the scope. So it sends a message to this switch, and this switch would have that responsibility to look for the MAC address of PC2, maybe BBB. So it'll be asking, hey, who is PC1? Who is 1.1.2? I need your MAC address. What's your MAC address? And so at this point, it is the responsibility of this device, switch A, to send messages to switch C and switch B. And so this guy will also send the same information to this guy, and this guy will send the same information to this guy. And so now you could see that on switch B, we have the idea of the MAC address table, just like this one. So this guy knows about, so PC1, it knows about PC1 being connected to, so AAA, assuming that's the MAC address of this one, with the MAC IP address of this. And then an interface of F0/3. This guy, so basically this guy would also have, what's the name? Maybe switch 2. Switch B would also have a MAC address table, and that MAC address table will have the IP address of BBB. But before that, this guy would send a message to this guy, and then it will be also recording AAA with the IP address 1.1 and also with the interface F0/0, F0/1. This is more like saying that, hey, I think now I know about 1.1, and if I want to go there, 1.1 is connected to my interface F0/1. And when this guy is replying, this switch will learn about that device as well, BBB, and will say, okay, that's 1.2, and it's connected on F0/3 before it sends the information to this guy. This switch receives it, and you'll see that, oh, BBB, which is 1.2, is connected on F0/1. So that's how switch A will get to that device. So we mentioned that sometimes because of the kind of redundancy we have, you realize that they send, if you try to go on and on and on, you realize that this guy gets to know about AAA from switch A, at the same time knows about AAA from switch B. So there's some kind of inconsistency in the switching table or MAC address table. And so it creates a loop, and then it goes in circles and circles and circles. And so spanning tree is that guy that will block one link and say that, let's make sure that all the traffic goes through one side so that we'll not have any conflict or we'll not have any kind of inconsistency in our system.